Before diving into data or training models, successful AI initiatives start with one critical step: understanding the business problem. This first phase of the CPMAI methodology, business understanding, lays the foundation for everything that follows. Without it, even the most advanced models will miss the mark. At its core, this phase is about alignment. You're bringing stakeholders together to agree on clear business objectives, define what success looks like, and ensure everyone speaks the same language before any technical work begins. It's where we stop thinking about the technology and start thinking about the mission. Now, what makes a good AI business question? It should be measurable, feasible, and impactful. For example, rather than asking, "Can we improve customer service?" we reframe it to something like, "Can we reduce customer churn by 15% using a predictive model?" That shift grounds the project in data and business value. It also gives us a clear yardstick to measure success. To further guide your thinking, consider the DIKUW pyramid: data, information, knowledge, understanding, wisdom. In the context of AI, data is the raw input: click streams, call logs, survey responses. Information is when that data becomes structured and contextualized. Knowledge comes from discovering patterns through machine learning. Understanding is what happens when we interpret those patterns. And finally, wisdom, strategic business action, is where the real value lies. The key is to ask, which level of this pyramid are we supporting with our AI effort? When scoping and prioritizing AI projects, tie your efforts to strategic priorities. Use a value versus feasibility matrix to weigh options. Consider the risks, the availability of data, and the likely return on investment. Start small, limit the scope to something achievable. Prove it. Then scale. This is where understanding the difference between a proof of concept and a pilot becomes critical. A proof of concept is about technical feasibility. It's often built in a lab setting with ideal or curated data. A pilot, on the other hand, uses real operational data in a real-world setting. It focuses on whether the solution delivers business value and can be scaled. Another key consideration: time to ROI. Simple automation projects might deliver value in 3 to 6 months. Mid-level machine learning initiatives, such as churn prediction, can take 6 to 12 months. Complex cognitive systems, like autonomous decision-making platforms, may take 1 to 2 years or more. Your time estimates should factor in data readiness, infrastructure, and how much organizational change is required. Increasingly, generative AI is accelerating this phase. Tools like GPT-based assistants can help with rapid prototyping, drafting documentation, creating synthetic training data, and even generating code for data pipelines. But tread carefully. These tools are powerful, but prone to hallucinations and compliance risks. Human oversight remains essential. It's also important to distinguish between cognitive and non-cognitive components in your project. Sending automated emails? That's rule-based and doesn't require AI. But interpreting customer sentiment from messages? That's cognitive, and a clear use case for AI. Similarly, recognize when to use automation versus AI decisioning. Automation excels at high-volume, rule-based tasks with structured data. AI shines when there's uncertainty, patterns to detect, or insights to uncover. Combine both for intelligent automation, RPA supported by machine learning. When defining your AI use case, map it to one of the 7 patterns of AI. Are you trying to personalize recommendations? That's hyperpersonalization. Classify images? That's recognition. Build a chatbot? That's conversational AI. Each pattern aligns with a type of business need and helps you scope your approach appropriately. So who should be involved at this early stage? You'll want data scientists to help define what's possible, but also citizen data scientists who bridge the gap between business and data. Domain experts bring the context that informs modeling decisions. ML engineers ensure technical feasibility, and your project manager or CPMAI lead orchestrates alignment across the team. Now, let's talk metrics. Define them before you build anything. If it's a classification problem, you'll want metrics like precision, recall, and accuracy. For regression tasks, maybe RMSE or MAI. But don't stop at technical metrics. Link your outcomes to business KPIs, cost savings, retention lift, conversion rates. And make sure to set thresholds for a clear go or no-go decision. That brings us to a critical checkpoint, the AI go, no-go assessment. Ask yourself, is the business problem clearly defined? Do we have access to quality data? Are stakeholders on board? Are expectations realistic? Can we meet the timeline? This is where you decide, consciously and with documentation, whether to move forward or rescope. Let's take two quick real-world examples. In one case, a company asked, can we predict customer churn with over 80% accuracy? It aligned with the predictive analytics pattern, and after confirming data readiness and stakeholder support, the team proceeded to the next phase. In another case, a chatbot POC for tech support showed strong intent recognition but weak escalation handling. The project didn't fail, it evolved. The team re-scoped it for phase 2 with a human-in-the-loop model. So, what are the big takeaways from this phase? Don't start with the model, start with the mission. Use the DIKUW framework to define data maturity. Identify where AI adds value and where traditional automation is enough. Use the 7 patterns to align technical work with business goals. Above all, remember, a strong business understanding phase sets up everything that follows in the CPMAI lifecycle. It's not just about building AI. It's about solving the right problem, with clarity, alignment, and purpose.